Alright, in this video I will be showing you how to do trigonometry proof and the A-star techniques for this, right? So when you get given a question, for example this question here, right? Cosec 4 theta minus cot 4 theta is equal to 1 plus cos squared theta over 1 minus cos squared theta. And we have to prove this argument, right? So, what we're going to do is use this algorithm on how to do this, right? So we start with the complicated side, right? Which is more complicated? I think it's this one here, because it's got the 4's in it, right? Then we think about answering this question. Can we simplify it or not? And if you can, then we have to use some algebra techniques. And if you can't, then we have to use trigonometric identities, alright? So, if we can simplify it, we can use difference of two squares, factorizing, expanding, adding a number, minusing a number. With this technique, it doesn't change the answer, but it gives us a way of making it identity. Then we could solve it. Cancelling and using identities such as tan theta is equal to sin theta over cos theta, right? Or using graph relationships, right? So, looking at this, we could see from this question, this is difference of two squares. Because this could be broken down into cosec squared theta plus cot squared theta, cosec squared theta minus cot squared theta, right? This is going to be broken down, and we're going to start from the left hand side, right? And we got this identity here, right? We know that this identity here is 1 from the identity, right? Because this is a well-known identity from the identity 1 plus cot squared is equal to cosec squared theta. And if you rearrange this, you get 1, right? Let's bring this to the other side, right? So now we're just left with now cosec squared theta plus cot squared theta, right? If you don't know what you're doing at this stage, what you can actually do is now start with the easiest side and then go through these steps. And what you're going to find out is that you're going to go forward this way, backwards this way, and eventually get to your proof solved, right? That's another way of doing it, right? And this comes time and time again in mathematics, right? And these are the standard identities that you can use. 1 plus tan squared is equal to sec squared, sin squared plus cos squared is equal to 1. 1 plus cot squared is equal to cosec squared, addition formula. And you can use what you call your double angle identities, such as sin 2 theta is equal to 2 sin theta cos theta. Alright? Now, what we're going to do is see if we can still simplify this further using these sort of identities here. Alright? So we know 1 over cos squared, we can use the third letter of this name to know what's the broken down version. And so therefore this must be sine, because it's an S there, right? Cot is cos squared over sine squared. Sine squared to 1 over cos squared like this. And we're nearly there. Look, compare this to that. Very close, right? And we know sine squared. Sine squared is equal to, let's just write it, the broken down version here. If you move this to the other side like this, you get that 1 minus cos squared aspect, right? And hence you proved it. So therefore this is to the right hand side. Proof done, right? So that's how you actually solve a trigonometry proof question, right? A couple of things that we could talk about here to just give you a bit more of that understanding aspect, right? With the graphs identities, what you can actually say is, if you want to convert, is sine pi over 2 minus theta is equal to cos theta. And the reason why you can say this is because cos and sine have a phase difference of 90 degrees between them, right? Another thing that you can do here is just use the concept of difference of two squares again, right? And we could manipulate that way, right? And that's how you could do that, right? And this is how you solve a question. Quite a complicated question using an algorithmic approach. and you're guaranteed a solution. And all these are the standard tricks that they use in the A-level mathematics exam, and these are what you could use to solve the question.